Hi, my name is Max and I'm from RIDGID, and I'm here today to talk to you about the SR20 line, pipe, and sonde locator. Basically, I'm going to talk to you about the function and the benefits and features of the SR20 locator. I'm also going to talk to you about some of the accessories that go along with the SR20 locator, such as a line transmitter, an inductive signal clamp, a remote transmitter, a floatable sonde, and the transmitter is inside your RIDGID SeekTech cameras. But first, let's talk a little bit about the SR20 and what makes it different than most locators in the industry today. First off is its appearance. There's these antenna balls and these additional gradient antennas, which we call. Now, these housings hold three distinct antennas offset by 120 degrees from one another. There's three in here, gives us 6 antennas, with 2 additional gradient antennas gives us a total of 8 receiving antennas for the locator. Now, what makes this really important is because of all the offset of the antennas, if I'm searching for a line trace using a transmitter, or I'm searching for a camera location, doesn't matter where that signal is coming from, I don't need to hold the locator in any particular direction, nor do I need to hold it at any particular angle in order to pick up the signal as strong as you possibly can. Another thing that distinguishes itself is the automatic gain adjustment. In traditional locating, in order to search for a signal, you sometimes have to sweep and turn the locator in certain directions in order to pick up the signal at maximum strength. You also have to adjust the gain levels if you're too strong or not powered enough in order to receive the signal. With the SR20, that eliminates that. The automatic gain adjustment will do everything for you, making it much easier for you, so there's no more hitting the buttons, adjusting the gain to keep the signal in your bandwidth. And lastly, the graphical display on the SR20 is very unique. Say you're doing a line trace. On the actual screen, which we'll show an example of in a moment, we'll show a set of crosshairs. That's your position. And on the screen, you're going to see a line. It could be cross, it could be straight up and down. But the line will represent the target line, or the line that you are tracing in the ground. That's for line trace mode. And in sonde mode or camera mode, the graphical display will actually show the direction of my pipeline, a physical outline of my pipe setup, show the center point of my sonde, and it'll give me the depth real time when I'm over my sonde. Okay? So let's talk a little bit about some of the accessories that go along with the SR20. So after we looked at the SR20, we're going to look at some of the accessories that go along with the SR20 that make it work in the field. First off, we're going to talk about a line transmitter. This is called the ST305. It's a 5-watt line transmitter that works in conjunction with your SR20 or even some of our other locators. This is the ST33Q arc transmitter, which is a more powerful transmitter in regards to induction of a signal. Now, basically, how these transmitters work is you use your leads. One lead goes to your actual piping material or your conductive material that you want to ignite or energize, and the other to a ground. Once you've hooked up your leads to your conductor, your pipe, your cable, your tracer wire, as long as it's conductive, and your opposite lead to a ground, you will now transmit a signal from your transmitter box onto your conductive line. You will then be tracing out that conductive line with your SR20. The signal from your transmitter is on your actual target line. You turn the SR20 on, and you'll actually see a physical representation of the line you are energized on the screen of the SR20. Basically, what you do is you put the line or the crosshairs over the target line on the screen of the SR20 and walk the line. In some instances, when you cannot hook directly up to your target line, say like on an electrical panel, a unit such as an inductive signal clamp may be used. The portion that opens up here and closes is actually the clamp itself. This portion plugs into the transmitter box, whether you're using the 5-watt or the larger Q ring. Anything that resides or passes through this ring will be energized at your frequency. Then, once again, you take your SR20 locator and then locate the line as we described earlier by keeping the crosshairs on the target line on the screen. What's kind of neat too about the graphical display on the SR20 is that it is showing you the target line in real time. What that means for you as the user is as I'm walking the line, I can identify, say, if the line makes a 90 to the right or to the left. On the actual screen of the SR20, you're going to see the crosshairs over the solid line, and I'm going to be walking that line as it shows. As soon as it starts to make a right-hand turn or a left or a 45 or even a T, you're going to see on the screen the line actually starting to turn as I'm walking beyond the turn in real life. So, in essence, I'm going to then force myself to put the crosshairs back over the line, and that'll force me in real time to make a right-hand turn or a left-hand turn if the line starts dropping off to the left bottom of the screen on the SR20. So it's giving us real-time information as to what the target line we are tracing is actually doing beneath us. The SR20 not only does active line tracing, say with your transmitter box, but it also does passive line tracing. Passive line tracing is used for when you want to identify buried underground utilities that you didn't know existed. Basically, you put the SR20 in the passive line trace mode, and there is residual current from other external forces that could be utilized or could be on actual target lines, such as water mains or gas lines, and the SR20 will identify those lines without actually having to actively hook up any transmitter box to some of those lines. The SR20 is outfitted with 60 Hz for electrical current flow, and also a bandwidth of 10 Hz to 35,000 Hz when it comes to passive line tracing. The SR20 will do line tracing whether it's active or passive, plus it will also do sonde location. Sonde location is a pinpointed target location from, say, whether a remote transmitter, a floatable sonde, or the transmitter that's located inside the camera of your SeeSnake RIDGID cameras. So how does that work? Basically, this is a remote transmitter, and this is kind of like a homing beacon. The signal will be emitted from this when it's inside, say, a conduit or a sewer pipe, or even your camera systems inside the sewer lines or a group of conduit will give off a signal, a directional signal, from the sewer pipe or the conduit. Place the SR20 in the sonde mode at 512 Hz, and the SR20 will then pick up the signal that is emitted from one of those transmitters. It will then take you over the target. It will then show you the direction of the pipeline that the remote transmitter or any of the other transmitters are sitting in. It'll give you an outline of what the pipe looks like, and it'll give you the depth of that transmitter in the ground. The SR20 is very accurate, fast, and easy to use when it comes to both line tracing and for sonde location. Let's try an example of both a trace and a sonde location using the SR20. We're utilizing a remote transmitter. Remember that the remote transmitter and the transmitters from RIDGID are all at 512 Hz sonde. Okay, we're going to utilize the SR20 locator for this particular sonde locate. So let's first now turn the transmitter on, the SR20 on, and make sure that we are in 512 Hz sonde mode. And you can see on the very left it says 512 Hz, and it shows a picture of a sonde. Okay, so immediately we see on the screen, the top left, a number 2715, and it fluctuates a little bit, but that is basically our proximity strength, or how close we are to our remote transmitter. So what I want to do first is maximize that signal. If I get closer to my target, or the remote transmitter, that number increases. It gets higher and higher. And basically until we get to a point where we can't maximize that signal anymore. Right now it's reading roughly 3,900 and some change, almost 4,000. So basically if I go to the left, it falls off. If I go to my right, it falls off. If I go forward, that number falls off. And if I go backwards, the number falls off. So roughly around 4,000 was our maximum signal. And now what I want to do is now dial in exactly our location and direction of which that remote transmitter is in. If you see the crosshairs in the center of the screen, that is my location and proximity to the actual remote transmitter. If I walk to the left, I see that there is a little iron cross symbol floating out there. I'm just going to place the crosshairs over that unit, and now magically appears a double outline. That basically represents the pipeline beneath me. If my remote transmitter was laying in the pipe beneath me, that's what the pipe would look like. Now there's also that dotted line in the center of the screen. That's called our equator line, and basically that cuts the remote transmitter, or any transmitter, right down the center. If I walk to the right, there is another one of those sets of iron crosses, and basically that's the other end of the signal. There's 2 poles, is what we call that, for every signal that we're trying to locate. So I found the one on the right, I found the one on the left, in dead center, right over this dotted line is the equator line, and where those 2 intersect, my pipeline and the equator line, is the signal or the transmitter right beneath me. There's the transmitter right below. And if you see at the bottom left of the screen, it says roughly 8 inches beneath me. So from the transmitter to the tip of the ball is roughly 8 inches. And it's just that easy to locate a remote transmitter or a camera location. Lastly, it doesn't matter which angle I hold the locator, it will always hold the pipeline true to form. So let's see a clear example of that real quick. Get over the target. And if I rotate the locator, you see how that line will pivot and hold itself true to form. Now let's do a sample line trace utilizing a RIDGID line transmitter and the SR20 locator. Now let's do a line trace using a line transmitter and the SR20 locator. Here we're looking at a 5-watt transmitter, and we're hooked up to a gas line, a gas tracer wire on a gas line, and we have our ground using a grounding rod. We have the transmitter on producing the signal, and we're going to use the SR20 line tracer. Once again, I'm going to turn the unit on and make sure that we are on the same frequency, 33 kilohertz, that we are on the transmitter box. Now immediately on the screen, let's see here, we're going to see a solid line on the screen and the crosshairs. The crosshairs, once again, is my position, and the line on the screen is the actual line that we are tracing or want to trace. You can see if I turn the angle of the SR20, I've now straightened out that line, and the arrow pointing to my right saying walk over to the right until I get the crosshairs directly over the line. There you have it. I can drop the unit onto the floor to give me a true depth. I'm reading 3 foot 4 inches in this direction, and it doesn't matter which way I rotate the unit, it's going to have or show the pipeline true to floor, true to itself in the ground. Now let's walk a little bit and see where this pipeline goes. Basically straight out to the street. It's a tad bit deeper when we get to the asphalt. Now it's reading 4 foot 2 inches. Center myself, get the exact read, and there you have it. 4 foot 1 inches below me. Doesn't matter which way I rotate this unit, it'll hold the pipeline true to form, making the SR20 one of the easiest locators to locate in the business today. And there's the pipeline that we traced.